Hello everyone, today I'm making the new movie in order to deliver you the chapter 3 for part 2. Okay, chapter 3 we already learned or we already studied part 1. The title of part 1, measures of location. In order to measure the location, we use some techniques such as mean, median, and mode. Okay, so in part 1 we were looking at how to find mean. In order to find mean, we need to use 3 types of mean. For example, the first one, arithmetic mean; second one, weighted mean; and the third one, geometric mean. Okay, so part 1 we also split into the other two parts, measuring location by using ungrouped data, and that's why from ungrouped data we need to find mean, median, mode from ungrouped data, and the other one we need to find mean, median, mode from group data. So we already learned how to measure location by finding mean, median, mode. Now we go into part 2. Part 2, measures of dispersion, data dispersion. So in order to measure or in order to understand the data dispersion, we will use some techniques. For example, here, range, mean deviation, variance, and standard deviation. So it's like the same thing as part 1. We use 2 types of data set, group data and ungrouped data. So first we will look at how to find range, mean deviation, variance, and standard deviation from ungrouped quantitative data. Okay, so this is the goals or objectives of part 2. So when when you have completed this part 2, you will be able to explain and apply the measures of dispersion, explain the range, mean deviation, variance, and standard deviation, explain characteristics, uses, advantages or disadvantages of each measure as dispersion. Each measure dispersion, for example, range, mean deviation, variance, and standard deviation. Understand Shelby-Sheff theorem and the normal or empirical rule as they relate to the set of observations. Okay, so these are the points that we continue from part 1. That's why you can see this is point 5, point 6, point 7, and 8. Okay, in part 1 we have studied about an average value of data set. Those average value is used in order to measure location. So in order to find average value, we need to find mean, median, and mode in order to determine the central tendency or central location of our dataset. But an average does not tell us anything about spread of observation, spread of values in our dataset. Okay, I have one case study. If your professors, teachers, or instructors asked you to walk across a river, not swim across, walk across a river, and he or she, your instructor, said that the river is averaged 1.5 meters in depth, 1.5 meters in depth. So if average of this river is 1.5 meters in depth, it's mean below our nose. That's why we can walk or we can breathe. Okay, we suppose that we don't know how to swim. That's why if you don't know how to swim, we cross this river by walking. Would you walk across river without additional information? Why? Why you decide to walk? Or why not? Why you decide not to walk? Okay, this part will examine or will study how spread of data is. How spread of data is. Okay, why do we study dispersion? Why do we need to study dispersion of dataset? In statistics, dispersion is referred to variation of each datum that means data item. The variation of each datum or each observation or each value in dataset. So dispersion refers to the variation of each data item, each observation or each value in our dataset. The arithmetic mean is a reliable average for a small value of data dispersion. A small value of data dispersion, it means arithmetic mean is more reliable when our dataset has no extreme larger value or extreme smaller value. That's why if our dataset has no extreme larger values or extreme lower values, the dispersion tend to be smaller. But it is not reliable average for a large value of data dispersion. So if our dataset has extremely large value and extremely small value, arithmetic mean cannot be used in order to study or in order to understand the average. Okay, average or midpoint value. It means average is not a representative of data because of the large spread of data. Thus, a measure of dispersion can be used to evaluate the reliability of two or more averages. Okay, so when we have a data set and our data set has some item with a larger value and some items with a smaller value, so in this case arithmetic mean cannot be used in order to represent average value or midpoint values because our dataset have a large dispersion. That's why in order to understand this dataset, we need to measure dispersion for the dataset. For comparing the spread in two or more distributions. So dispersion is used in order to compare the spread of data in two or more distributions. Okay, now this is the reason why we need to study dispersion. Okay, because we want to understand the variation. Is it a big variation? Is it a large variation? Or is it a small variation? Is it a small variation? Or is it just small variation also? It's small variation. Okay, measures of dispersion by using ungrouped data. Several measures of dispersion such as range, mean deviation, variance, and standard deviation are used in order to measure dispersion. Range. Range is based on the location of the largest and the smallest values or items or observation in our dataset. It is the difference between the largest value and the smallest value in our dataset. So how to find range? In order to find range, you need to find the largest value that I label capital H and the smallest value in a dataset that I label capital L. Okay, so this is the formula how to find a range. That's why in order to find a range in one data set, you need to find H, capital H, and you need to find capital L. So by taking H minus L, so H minus L, this is represent the difference. Okay, H minus S represent the difference between largest value and smallest value in our data set. The other method is mean deviation or mean absolute deviation. You can call mean deviation or mean absolute deviation. In short, we have MAD. Is the arithmetic mean of absolute value of deviations from arithmetic mean of data set. Is the arithmetic mean of absolute value. What does it mean, arithmetic mean? Arithmetic mean, that means the sum of what we study divided by n. Okay, or divided by n. It depends on sample data set or population data set. So this is arithmetic mean or absolute value. Okay, is it absolute value? It should be this one. Absolute value or deviation from the mean. A deviation from the mean should be minus 8 bar. Okay, deviation from the mean. Okay, you can see formula. It takes into consideration all of values in sample data set. Okay, we use sample data set, not population. So this is formula. Arithmetic mean or absolute value. This is arithmetic mean, absolute value. Okay, arithmetic mean, sum divided by, and this is arithmetic mean of absolute value from deviation. This is deviation. This is deviation. Deviation from the mean to item or our data set. Okay, so this is how to find mean deviation or mean absolute deviation. So in order to find mean deviation or mean absolute deviation, first you need to find H bar. H bar is arithmetic mean. Then you need to find deviation is because ungroup, that's why this is item. Any item from our data set to the mean, and then we put absolute sign, absolute value, and then we need to find the other arithmetic mean. In order to find the other arithmetic mean, we add them divided by n. Okay, so first, once again, find mean, arithmetic mean. Then you need to take every x minus mean. Then we put absolute in order to eliminate, the sign, no negative, no positive sign. Then we add them together divided by n. Okay, what is n? N is total observation in our sample data set. xi is the values of observation at i's, and x bar is arithmetic mean of value. Xi minus x bar is deviation of from the mean to each value. Okay, this is a formula. So in order to understand, in order to make it easy to remember this formula, we need to have more practice. More practice can help you to remember this formula. Okay, question, answer. Question: here is the number of students in statistics course for the latest 5 years. That's 5 years. This is last year, last 2 years, last 3 years, last 4 years, last 5 years. Okay, this is number of students taking statistics during the last 5 years. Last year, last 2 years, last 3 years, last 4 years, last 5 years. What is the range of number of students taking statistics? Compute arithmetic mean of the number of students. Calculate mean deviation of the number of students. Okay, we have 3 questions based on this by using ungrouped data. Ungrouped data, this is a sample one. Okay, in order to find a range, you need to find the highest value and you need to find the lowest value. So maybe it's easy because this is a less number of items in our data set. That's why we can see that this is highest value from our data set, this is lowest value of the data set. So range in our data set is 45. 45 is the difference or the gap between the largest value and smallest value in our data set. In order to find arithmetic mean, you need to add all of these values together and divide it by number of this value. Okay, that's why if I add all these values together and divide it by number, how many? 5, because 5 years. That's why arithmetic mean is 304.2. It means that every year during the last 5 years, the average number of students taking statistics is 304. Okay, in order to compute mean deviation or mean absolute deviation, we need to transfer here from horizontal to vertical. Okay, this is horizontal, this is vertical. This is original data, this is what just found in terms of arithmetic mean. So based on our formula, mean absolute deviation is a deviation of the mean to the deviation from the mean to all item, and then you need to find arithmetic mean again for this one. Okay, so based on the formula, first we have x. Yeah, we have x now. We have x now. We have x bar now. What we need to do next? We need to find deviation. Okay, define deviation by taking x minus x bar, x minus x bar. So in this case, you can see some results have positive sign, some results have negative sign. Okay, so we don't want to see positive, negative sign. That's why we put absolute value here. Okay, we put absolute value. Because if we don't put absolute value, if we add them together, this is adding, sigma adding, that's why it will be 0. It's wrong. So don't add all of these values together without put absolute value sign. If we add them together, must be 0. If it's not 0, this is not the correct mean. Okay, I think you still remember from the characteristics of using mean. So next we add absolute value. That's why you see there's no sign, no positive, no negative. So we can add them together. If we add them together, based on our formula, we need to divide it by n. What is n? 5. So mean deviation is 13. What does it mean? It means 13. It means during the last 5 years, every year the average number of students taking statistics is 304. But some year in average more than 304 by 13. Okay, some year the more student from our average is 13 more. Some year the less student from average is 13 less. So mean deviation is the gap between highest value to the mean and lowest value to the mean, but in this case in terms of average, not in terms of actual. So I can say that in average number of students taking statistics during the last 5 years, every year 304, but some year in average again greater than average by 13, some years less than average by 13. Okay, so this is about average. This is average, and then 13 higher in average, 13 lower in average. So this is mean absolute deviation. That's why this is deviation. This is deviation. Okay, so this is mean deviation. Now maybe a little bit faster, but you can review this many times as you can. Okay, if you go to page on your textbook, if you go to page 78, you can see cell review 3.6, and if you go to page 79, you can see exercise. This exercise is your for homework, though, so the number that you do for the exercise is even number. Okay, even number. Okay, we go to textbook 78 is this one. This is mean deviation, and you can see this one, and you can study example here. Based on the textbook, you can see study example on page 77. They have question and they have solution for you. Okay, and down here they have some explanation. Maybe I'm not reading this one for you. You need to read by your own. Okay, this is cell review 3.6. So you have ungroup data set. They ask 3 questions like I ask in our slide here. Okay, this is an exercise that you need to do in on the page 79. What you need to do is even number is number 36, number 38, number 40. Is it 40? Wait, why I don't highlight this one? Maybe something special. The sum of 8. Okay, this one also number 40. So the number for this exercise, this is for the exercise, you need to do number 36, 38 and 40. Okay, so cell review. Okay, I just remind you, cell review is not homework, so you don't need to submit. You need to practice by your own, and you need to compare your result to the textbook result, or you need to compare your answer to the textbook answer. That's why cell review you don't need to submit. What you need to submit as homework is exercise. Okay, exercise on page 79, exercise number 36, number 38, number 40. Okay, rank already done. Mean deviation or mean absolute deviation is already done too. is already done. Now we go into variance. Variance for ungrouped data set. Variance is arithmetic mean or square deviation from the mean. Actually, variance is similar to mean deviation. It's similar to mean deviation, but what the difference is? What the difference is? Mean deviation, this is we put absolute sign without square. Okay, without square. Mean deviation, we put absolute sign here, but no square. For variance, we don't put absolute sign, but we take a square, and then we add them together divided by n. This is capital N because this is population. Okay, so population variance can be found by this formula. You need to find first. You need to find mean or population mean MUI, and then you need to find the deviation from each value of our population data set to the mean, and then you need to take square, and then you need to take square. After that, add them together and divide it by n. Okay, so in order to find population variance, you need to first find population mean, then we take a variance or deviation, not variance, we take deviation from h to the mean, and then take them as a square result, take all these result as square, and then add all these together and divide all of this by n. This is population variance. N is total observation, total items in our population data set. H bar is value of each data item in our data set. MUI arithmetic mean of our population data set. Sigma square represent population variance. Okay, so if you have population variance, we can find population standard deviation by taking a square root. Just taking a square root of variance, taking a square root of variance, yes, so here a square root of variance. This is a standard deviation. Range and mean deviation are easy to interpret, are easy to explain, are easy to present. But variance and standard deviation are not really easy to interpret for a single set of observation, as they are in square, especially variance. So normally we don't explain variance because in square. Okay, because variance in square, that's why variance in square, so it's not easy to interpret. However, standard deviation is a little bit more easy because no square to interpret. Okay, you can go to again textbook. If you go to textbook on page 80, sorry, 80, you can see standard deviation variance here. You can see study example here, and they have solution for you. They also have some explanation here. and then this population standard deviation, and you have cell review 3.7, and you have the other exercise for homework 42, 46. It should be 44. Why not 44? Okay, so 42, 44, 46. Yes. So you need to study exam problem, and you need to practice, and then you can do exercise as homework. Okay, this is a population standard deviation, population variance. How about sample? Unlike population variance, for sample dataset, the variance can be calculated or can be estimated by two methods or two formulas. First one is a conceptual formula, and second one is computational formula. Okay, so this one is conceptual formula. It's similar to the one that we have looked previous slide, population variance. But the difference from population variance and conceptual formula for sample variance, we divide it by n-1 for sample, but we divide it by n for population variance. Okay, but the other side here is the other formulas that we use in order to define or in order to calculate the sample variance is computational formulas. For computational formula, we don't need to find arithmetic mean. Okay, so by looking at this one, we don't see H bar. That H bar stands for arithmetic mean of the dataset. Okay, so when you look at for a second to look at computational formula, you think that you may think that these two factors are the same. Okay, these two factors are the same, but actually they are not the same. So try to look at this carefully in order to understand, in order to get clear understand. Okay, actually they are not the same. For example, you can see these factors. This should be come from x square and then add all x square together. By looking this side, this factor, it should be x, but add all this value h together and then take a square. Okay, so you must be clear for this formula, but in practice or during practice or during quiz or exam, in order to define, to calculate sample variance, you can use conceptual formula or computational formula. You don't need to use both of them. Why? Because both of them, by using the same dataset, they will provide you the same result. That's why we don't need to use both of them for finding or calculating sample variance by using the same dataset. That's why you can use one among two here. Which one that you think more easy for you? Okay? Which one that you think more easy for you? Conceptual formula or computational formula? Okay, so again, in order to calculate sample variance, we have two formulas, conceptual formula and computational formula. Note that this is divided by n minus 1. But when we find population variance, this is not divided by n minus 1, divided by only n. Okay? Only n. Some textbooks, but those textbooks are not statistics textbook. In order to find variance, sample variance, they divided by n. You can ask, why some textbook they divided by n in order to find sample variance, but statistics textbook they divided by n minus 1. Statistics textbook is more specialized than the other books. That's why they divided by n. But it's not wrong if you divide it by n, the sum of this value, and divide it by n in order to find sample variance. It's not wrong, but it's better to divide it by n minus 1. Denominator, that means the number below the bar. Okay, denominator is here, n minus 1. So denominator of n minus 1 provides appropriate correction for this tendency rather better than n. Better than n. Okay, that's why remember that in order to calculate sample variance, you need to take the sum of this value divided by n minus 1, not n. N minus 1 is better than n. So result will provide you more accurate if you provide than the result that you get by taking this value divided by n. Okay, what is n? N is number of observations value in our dataset, sample dataset. X is the value of each item or each observation in our dataset, sample dataset. H bar, okay, we use H bar when we will have H bar when we use conceptual formula. But if you use computational formula, we don't need, or you don't need to find H bar. Sigma square, this is not S, it should be this one. It should be like this one. Okay, sigma square. So this is the way how to write the correct one, not S. This is sigma. Sigma square stands for sample variance. If you know sample variance, you just take square root. You just take square root of sample variance. You will get sample standard deviation. You will get sample standard deviation. Okay, this one. Okay, so come to practice. For example, we have one sample dataset. The number of, or the total observation in our data set, 6 items or 6 observations. The topics that we study in this example is weekly spending, student weekly spending. Okay, that's why we have a sample data set with 6 students. So if we have sample data set with 6 students, our data set should be 6 weekly spending. That's why we have here. Based on this sample data set of student weekly spending, compute variance and standard deviation of this sample student weekly spending. Okay, so now let's check by using the same data set but 2 different formulas. So the same data set but using two different formulas. So what happened to these two formula results? Okay, first I will use conceptual formula. In order to use conceptual formula, we need to find x bar. That's why column 2 is x bar. Then I need to find deviation from x to x bar. That's why column 3 deviation. Okay, because by one formula. Next, I need to take x minus x square. This is column 3. Then I need to add them together. Okay, so in column 3 I can add them together. Then I divide it by n minus 1. Okay, I divide it by n minus 1. After that, I just take square root. If I stop by this, it should be variance. Okay, it should be variance of our data set. But if I take a square root, this is standard deviation. Okay, so let's go. Now I have column x, I have column x bar, I have column x minus x bar, I have column x minus x bar square. Okay, so who remember how to find arithmetic mean of our non-group data set or ungrouped data set? How to find arithmetic mean for ungrouped data set? In order to find arithmetic mean, you need to add all x together and then divide it by n. Okay, so add all x together, then divide it by n. What is n? N is 6. 1, 2, 3, 4, 5, 6, because 6 students in our data set. So now I have mean, weekly spending, average weekly spending of student. So I take it into column 2. Then I take x, I have x, I have x bar. That's why every row here I take x minus x bar. X minus x bar, x minus x bar, x minus x bar, x minus x bar from the first x up to the last x. That's why I got x minus x bar result. So I need to take a square. Then I add them together. Take it divided by n minus 1. 6 minus 1. So this is variance. In order to get standard deviation, you need to take square root of variance. Okay? So our standard deviation is approximately or around 23,000. What does it mean? 23,000. So we interpret 23,000 to the mean. In our sample data set with 6 students spending, weekly spending, every student in average they spend 91,500 real per week. Okay, all 6 students in average spend this amount, but I want to know in average again who or how much is the most spender, or how much is the largest spending, or how much is the lowest spending. That's why in average the weekly spending is around 91,500 real. In average again, the richest spending is more than average by 23,000. The poorest spending in our dataset, the poorest student spending for weekly is below average by 23,000 real. Okay, so that's why it's called deviation. Deviation upper average, deviation lower average. That's why one deviation and one standard, sorry, not one deviation, one standard deviation. This is one standard deviation. So again, based on the data set, we found that weekly spending in average weekly spending for these students is 91,500 real. Amongst the students, some students are richer, some students are poorer. So how much that the richest spend per week compared to median or compared to average spending? How much is the poorest spending per week compared to the average spending? That's why this is the richest. They will spend in average higher than average spending by 23,000, and the poorest will spend in average less than the average spending 23,000. So this is the meaning of standard deviation. Okay, so we compare, this is average spending, and then we want to know the highest and the lowest spending in average. This is not actual. Okay, by looking at actual, you see this is the largest spending, this is the lowest spending, but actually they are not here because this is actual, this is average. This is average spending out of the group, but this is average most spending, the most average spending, the less average spending. So 23,000 less than average by 23,000, more than average by 23,000. Okay, now I'm using computational formula. In order to compute variance or standard deviation by using computational formula, I use only two columns. This is original column, this is a new column, h square. Okay, h square. Why I need to find h square? Because here I have to find h square. That's all. So based on formula, I have h square and then I add all of them together. This is called summation. It will be like this one. And this one I have x. I add all of it together and then I take a square. I got this one. Okay. You see? This one. This is summation of x and then take square. Divided by n and divided by n minus 1. This is variance and this is standard deviation. You can see they provide you the same result from different formula, but offer us the same result. So that's why in practice, in quiz, in exam, you need to use only one formula in order to compute, in order to calculate sample variance or sample standard deviation. Okay, so now come to the end for measuring dispersion by using ungrouped dataset. Okay, before finishing measures of dispersion by using ungrouped data, you need to go to your textbook to practice examples on page 83 and 84, cell review 3.8 on 84 on page 84, and exercise as homework on page 84 and page 85. Okay, if you go to textbook, you can see this is an example on page 83, and this is an example on page 84. And on page 84 you have cell review 3.8 and exercise 84 and 85. Exercise number is 48 and 50, 52. 48, 50 and 52. Yes, this is for exercise. Okay, now it's time for you to study, to watch and study and practice example, cell review and answer exercise as homework.